Alright, we're going to look at the last section from chapter 3. This is on proportional and non-proportional relationships. These are a special case of linear equations that are related to what we talked about before for direct variation. So, first our vocabulary, definitions. Proportional relationship is any relation in which the variables are proportional. So it's pretty simple definition. Proportional means that when one increases or decreases by a certain ratio, the other also increases or decreases by a certain ratio. So proportional relationships really are the same thing as direct variation. That means when one variable increases or decreases by a certain ratio, the other goes up or down by the same ratio. So a non-proportional relationship, pretty obviously, is one in which this is not true. They're not proportional to each other. Okay, so we're going to look at some examples of both of these. Problem-solving tips. Proportional relationships, aka direct variation, because it's a direct example of those. They, number one, always pass through the origin. That's critically important. If you have a line or a relationship that doesn't pass through the origin, it cannot be a proportional relationship. Second thing is, for linear equations, the proportional relationships, the non-proportional relationships are going to be shifted up or down. So if you take something that's a direct variation line that goes through the origin and you slide it up or down, then it will suddenly become a non-proportional relationship. And I'll show you what those look like on the next slide. So if you want to find the equation for these non-proportional relationships, the way you do it is you first start off by finding the slope. And you look at this part here. So this part is your proportional part. And this is what you have for direct variation. Instead of f of x, we called it y equals, instead of the slope, we called it k times x. But really here, it's just y equals kx, f of x equals mx. So if you add in the amount shifted, this is the part that makes it non-proportional. So if you don't have any shift up or down, you're looking just at y equals kx for direct variation, or f of x equals mx, which is a proportional relationship. If you add or subtract any number from that, then you're no longer proportional. So m is the slope, k is the constant of variation, but they have the same meaning, really, in these kind of problems. All right, let's just do two examples to kind of get a feel for what this looks like. If we have a graph, we can look at this and see here's our linear equation. You can see right away it's non-proportional because it doesn't go through the origin, but it does have a slope because it's a straight line. So let's try to find the slope. Remember that slope, gosh, my messy handwriting. Slope is rise over run. Okay, so pick 2 points. Let's go from here to here. I had to go down 2, so my rise is -2, divided by my run, which is forward 2, which is +2. So -2 divided by +2 is -1. So there's my slope. Okay, so I have y equals 1x plus or minus my amount shifted. Okay, or I could put f of x here if I wanted in function notation. So f of x equals y, same thing, which equals 1x, 1 times x plus or minus the shift. So let's look at our shift. The line, if it would have gone through the origin with the same slope, would look like that. So I can see it got shifted up 2. So my shift right here was up 2. So my equation, my final answer here, for this non-proportional relationship, f of x equals 1x, which I can just write as x, plus 2. Okay, I know that you may have already learned this as mx plus b, so this is your b value or y-intercept. But right now we're going to look at it as a shift up or down from our basic line through the origin in the middle. So this is standing for a shift of 2 upward. And this has a slope of, oh, I've made a mistake. Can anyone see what my mistake is? Anyone see my mistake? Here, my slope came out -1. I failed to put in this minus sign, so make sure you go back and put in that minus sign. So the slope equals -1. All right. Second example problem. Here we go. In this one, we're given a data table instead of a graph, so we can still find the slope. Remember, to find the slope, you pick 2 points, and you can use this version. It's actually y2 minus y1 divided by x2 minus x1. I almost got that upside down. So let's pick this point as point number 1, and let's pick this one as point number 2. I'm choosing these two because I don't like dealing with negatives. They make me make more mistakes than I need to. So y2 minus y1 is going to be 8 minus 0, divided by x2 minus x1, 4 minus 0. 8 over 4 is 2, so my slope is 2. And I go through the origin, so this is proportional, because it's not shifted up or down if it goes through the origin. So my equation, f of x equals slope, which is 2, times x, and then plus or minus the shift, but the shift was 0 because I'm in the origin. So my equation is like that, and it's proportional. If I double the input, I will double the output. So for example, if x equals 5, f of 5, which is my output, 5 times 2 is 10. If I double the input and I try x equals 10, then f of 10, I put in a 10 here, 2 times 10 is 20. So I double the input, I double the output. That's an example of direct variation, also called proportional relationships. Over here, if I double the input, I will not double the output. Let's check that real quick. Let's try f of 5. f of 5 equals, if I plug in a 5 right here, I get negative 5 plus 2, which is negative 3. And then let's try f of 10. Okay, if I plug in negative 10 plus 2, I get negative 8. So you can see that when I double the input from 5 to 10, I did not double the output, so it is not proportional, whereas over here it was. Alright, we'll do more examples as always in class, and come prepared with any questions that you have. See you there.